Question 2. This question is about alcohols and carboxylic acids. Alcohols are used as fuel. The student burned 1 gram of 6 alcohols and determined the energy released from each. Table 2 shows the results. Question 2.1. Calculate the mass of ethanol that must be burned to release the same amount of energy as burning 1 grams of heptanol. So this is heptanol. The energy we get is 39.8 for 1 grams of ethanol. And for ethanol, for 1 grams, we get 29.6. But we want to go from 29.6 to 39.8 of ethanol. So we want this ethanol to give us 39.8. We're trying to find a mass that will correspond to that. So what we can do is, we're going to that way, we want to go from there to there as well so that we can go from there to there. We can divide these. If we divide 39.8 by 29.6, we get 1.3, which means we need to times it here by 1.34. So if we times it by 1.34, we get from 29.6 to 39.8. That will give us, so times this by 1.34 to go there. So we have to do the same here, which means we times that 2 by 1.34. So 1 times 1.34 will give the mass of 1.34 grams. Question 2.2. The energy released in kilojoules per grams varies with the number of carbon atoms in 1 molecule of each alcohol. Plot the data from table 2 on figure 2. So here's the table. We're plotting the number of carbon against the energy. On the x-axis is the number of carbon. So that's the number of carbon on the x-axis. And on the y-axis is their corresponding energy. For 2 carbon, so we come here, 2 carbon would have a 29.6. So that would be somewhere there, 29.6. This is 29.246. That'll be 29.6. And so if you do that for all of this, for 3 carbon, 33.6, 3 carbons, 33.6 here. And for 4 carbon will be 36.1, so that'll be 35, 36, 36.2, 36.1. Yeah, so this is what we get when we join them together. Question 2.3. Estimate the energy released in kilojoules when 1 gram of octanol, 8 carbon, is burned. Well, so we want to go back to the table here, and we want to estimate the energy when carbon is 8. So this is 8 here. We want to trace it up here. So that's what we do. And we trace that up. We get that. And that is 40.6. So we want to come back here and we want to write 40.6. Question 2.4. Carbon dioxide is produced when alcohols are burned. Carbon dioxide is identified by bubbling the gas through lime water. Complete the sentence. Choose the answer from the box. Lime water is an aqueous solution of calcium hydroxide, and this is the formula for calcium hydroxide. Question 2.5. Give the result of the test when carbon dioxide is bubbled through lime water. The lime water will turn milky or cloudy solution. Question 2.6. What is reacted with ethanol to produce ethanoic acid? Tick one box. A halogen? No. An alkaline metal? No. An oxidizing agent? Yes. Water? No. Here is the ethanol, and with oxidizing agents such as the potassium permanganate or potassium dichromate, acidified, that's what that meant. So you have to acidify it, and we call that this or that oxidizing agent, and that's what they're saying. And your product will be ethanoic acid, and that's ethanoic acid. So what's going on here is the oxidizing agent is represented by a little square box like that with O, and the O in the middle is basically removing 2 hydrogens from there. You can see there's this hydrogen is there, but those 2 hydrogen are gone. That's missing. So the O will take away those 2 hydrogen and then produce water. So we could finish it by saying plus water, and that's the operation that took place there. That's why it's called oxidizing agent, because it's basically removing 2 hydrogen, and that's oxidation process. Question 2.7. Ethanoic acid contains the functional group. This functional group here is organic acid or carboxylic acid. Complete the display structural formula of this functional group because it's been displayed, so you want to show these elements. And so what we start off with this methyl group here, that's the CH3 is in there, so that's CH3, and this C is that one, and you can see it's bonded with double O for oxygen, so we need to do that. So it's also bonded to hydrogen there, OH, so now OH, and we need to do this, so that will be the double O bond here. And that's the display structure. Question 2.8. Ethanoic acid reacts with different compounds. Draw one line from each compound to a product of the reaction of the compound with ethanoic acid. So this ethanol reacting with ethanoic acid will produce ethyl ethanoate. So the link will be, so that will be the link there. And the sodium carbonate reacting with ethanoic acid will produce the carbon dioxide gas from the carbonate. So when you react the ethanol here with ethanoic acid, you can see that the H and the OH here, or if you like OH here and H, whichever way you want to say it, will produce water, and then the rest will join up to that or to that carbon. So we can then do that and then say, okay, this is what happened. You see, that's the rest of this joining up to there, where that H is gone to form the water here, and that goes away as water. So we'd expect to get plus water, H2O. But for the sodium carbonate and ethanoic acid, here is sodium carbonate, and that's ethanoic acid. We happen to need 2 stoichiometric mole to produce the reaction to completion. We have the H is gone because this is an acid, and sodium joins it. That's why we got the CO double bond here and ONA. And because we got 2 sodium, so we need 2 of these to form. So we have to put that 2 there. Thereby we have to multiply that by 2. And then we're creating carbon dioxide from here. That's carbon dioxide plus 1 oxygen, which then goes with 2 hydrogen there to form water. And that's the reaction for that. So this is the carbon dioxide here, and that's sodium carbonate here. So we could write for the final one there, so we could write plus H2O.